Начата запись встречи.
And now the class number 14, Introduction to Aerospace Introduction into Aerospace Engineering, don't forgive me, manufacturing, or Introduction into Major, as it's given in your curriculum. And that is the 14th class. After this, we're supposed to have class number 15, 16 really online. And in this last class, we need to talk about the dreadful subject, the most unfavorite topic of all the students, coordination. It's a student after studying the topic, you see. No, really not. Actually, this picture I took from some story about evolution theory, how from the same object, from the same animal may appear completely different types of animals or plants or whatsoever. But it's greatly illustrate idea of spoiling of sizes during manufacturing process. Especially why it's important for aircraft manufacturing. During the studying, you already understand we practically do not use so-called direct metal forming, metal or whatsoever. Shapes and sizes of objects may appear as a result of secondary forming. It means that we copying the sizes of tooling by our parts. So first we produce tooling, next we produce on this tooling we produce some shapes and sizes, and finally they will meet in assembly jig, which is also produced in some from some pieces and with using of another tooling. That I hope you already do remember. And here is illustration of idea how little deviation of shape, size, and color. You see the this gradual changing in each the line, and you understand how it's maybe finally do imagine at the assembling we need to meet objects being produced from the one source of information, but next they goes with different way. What different ways? On one hand, we have some parts that produce it immediately with grounding, with basing on the information of drawings, but it's very few parts in aircraft, really. Mostly it comes about the parts, so-called stiff mechanical components, massive mechanical components, or bulk mechanical components that looks like gears or landing gear legs or something like this, some massive elements. And most of another components of the aircraft produced from sheets, extruded profiles, they are much more delicate, and they have complex shapes, and they have to be produced by using of special tooling. For instance, here is let it be the line that responsible for manufacturing the tooling and manufacturing of parts on the tooling. And third line, we also have assembly tooling, and this assembly tooling finally meet all the parts produced either directly from drawings or parts produced on the tooling that was produced either from another tooling or from drawings, and so on. Story not imaginable for you yet must be, it's will be probably too much boring, but story it's important in order to give you idea about the main approaches in aircraft manufacturing, and mostly even not in manufacturing. Manufacturing it's already deal with results of providing of coordination in pre-production before manufacturing. Well, and what you see right now, you see direct translation from our standard, our Ukrainian standard, but similar standards we have in all the territory of former Soviet Union, and similar terminology is used in all our countries, but of course not in English. In English, actually supposed to be here with a dash, co-ordination. And in English, it's practically not possible to find information about these matters. Moreover, in the view of systematic explanation, I may show you, let's say, tracks of this information in some sources, but practically there is no system of explanation about these matters. What all this about? Let's come back to the things that we discussed some minutes Not minutes. For you, it was not minutes. Sorry. Maybe you're watching it immediately after. Maybe you watched it a week ago. That we discussed it in previous class, number 13. Matters of accuracy, errors, preciseness, and other things. And I've been reminding you or give you get you some idea, like familiarize you for the first time. I don't know what kind of students you are. I'm already not certain that you're all from engineering colleges. So idea about geometrical accuracy is about what? That we have sizes given in documentation, sizes given in the some drawing, for instance, and or 3D model in actual conditions in our circumstances. And it's should be implemented into life, realize it, and after we realize it, moreover, you do remember we produce not one object, we produce the whole program, some amount of objects that correspond to demands of customer, how many they need of these objects. And finally, we see that all these objects, they a little bit deviate. Their actual sizes, they deviate from the information given in the drawing. This deviation is called error. Difference between real size and size in the drawing, it's error. It's understood as error. Error actually is quantitative characteristic of accuracy. Accuracy is degree of correspondence of object, of size, of whatsoever, of real object to our expectation or to technical documentation, for instance. And accuracy, no, you see here is another names may be used not quite corresponding to what we have seen in American or European documentation. Whatsoever, you already understand what it comes about. It's accuracy of one object, accuracy of size. But no, let me to show you some pages in the book that referred to the matters we study. And here is also the chapter which explain the rules of calculating of dimensional chains. Rules of calculating of dimensional chains not necessary for us right now, and you study or you already studied it or you will study it in another disciplines. But story is that dimensional chains may belong to either one object or to some objects, to assembly unit. And in assembly unit, we have so-called conjugations, places of contacts of one object with another object. And when we're talking about the airplane, I'm already said it sometimes that we are not so interested in accuracy of individual sizes. We are interested in accuracy of conjugations. And conjugations is, no, here is not correct using of term, should be concept of coordinations here. Conjugations, accuracy, it's determined already like this. Accuracy of conjugation, what we understand as conjugation, difference, no, it's something should remind you that story about fits. Object A, object B, and their difference with sign minus or with sign plus, finally it will be, their difference in previous class, this difference was considered with name fit, do forgive me, and difference of these objects given in the drawing may deviate from difference of this between these objects in their sizes that really exist. So when we're talking about the conjugation characteristic of accuracy characteristic of conjugation, we already talked not about absolute value of size. We're talking about the difference between two sizes, shaft and hole, for instance. And what is the difference of sizes given in the drawing and difference of sizes that we produce it in real. And difference of these two differences we call the error of coordination. Finally, if no, typically in class we just show, no, but not in class of this discipline, in higher classes on third year, we show how formula number 8.1, how it's transformed into formula 8.2. If you'd like, you may do it on your own or just trust me on my word. It's simple. It's just a recomposition of formula. And finally, you will see that it's object A real minus object A nominal minus object B real minus object B nominal. And finally, we understand that accuracy of conjugation, it depends on accuracy or error, better to say, let's use word error now permanently, that error of conjugation equal to difference between two errors. We are interested, once again, remind you, in the error of conjugation equal to 0. Now, let me to show you once again. For instance, error of conjugation, maybe I already explained it in previous classes about this discipline a month ago for me, so really not sure explain it in details or not. Look, here is accuracy of conjugation of object, or error of coordination should be called, sorry. Error of coordination object A and object B, which is equal to error of object A minus error of object B, as it's said in this textbook. Yes, I may demonstrate it with ease how this formula I said translated into this one, but let's not spend time on this. We need this thing equal to 0. How we may reach it? No, it's somehow in line with the story about accuracy and precision. Look, 0 minus 0. Accuracy, error of coordination equal to 0. Accuracy of coordination is ideal, you see? What if objects are not ideal? For instance, one object has error 5 and another object has error 5. In conjugation, what it will be resulted in? Sorry, let's increase the field. What it will be resulted in, you already understood. Idea is idiotic, seems like, but it's work in life. If in conjugation they have the same error, final error of coordination and assemblability, they will be ideal. If even they have 20 minus 20. Now, of course, we understand that it's like over image. 0. So what we should strive to reduce accuracy of, to reduce error of partial objects, of individual objects. We should have provide all the possible ways to reduce differences between of these objects in terms of increasing of their assemblability. And of course, there is some balance in aircraft manufacturing, but on the first point is idea that error of coordination should be 0 or close to 0 in order to provide assemblability without adjustment, without additional work, without spending money, time, labor input, and so on. On one hand, we may talk about, look, here is the interchangeability. Or we may talk about interchangeability. What is interchangeability? The property of object that show this object is usable instead of another object without additional work, without adjustment of sizes, without changing of volume or some other properties. No, in the most general meaning. When we're talking about interchangeability of structural components, mostly we talk about their geometrical interchangeability. Of course, there are different kinds of interchangeability. I also hope you remember this, that it comes about geometry, physical properties, mechanical properties, chemical properties, and functional properties, functionality of the object also may be interchangeable or not interchangeable. And instead of goes into examples, let's continue, because usually I spend too much time maybe for examples. Look, interchangeability is provided it's directed on the providing of properties of one object A or object B. But when we're talking about the coordination, we always talk about couple of objects, and coordination is directed for providing the minimum difference, let's call it, between object A and object B in conjugation. Not to be frank, it's not completely like this, because when we studied during some classes, during some lectures, we understand that objects of coordination, they may elements of coordination, let it be according to our standards, they may belong to the same object actually, but they are either of different nature or placed in different places. And what in our aircraft manufacturing, objects of coordination on one hand, assembly component, on other hand, objects of coordination are tooling, elements of tooling, whatsoever tooling, for manufacturing of parts or for assembling. And we, looking at this, we may understand that couples of objects, this one and that one, when we're talking about cases of coordination, may be realized in the view assembly component to assembly component, coincidence, coordination. It's not complete coincidence, maybe. And it's maybe coordination, we're talking about some parameters only. Next, assembly component to assembly component, to tooling, to element of tooling. What, for instance, nose rib, it's manufactured in a shop, yes. And next, it should be inserted into some element of skin. And there are elements of their coordination. Where these elements of their coordination? Well, certainly it's obvious. Contour, outer contour of rib, spoiled, thank you. Outer contour of rib and inner contour of the skin. I didn't try to draw it twice here, but you understand, skin has thickness. Well, one more problem, what assembly component tool. Next, we place the skin into assembly jig. Assembly jig, no, in the most general way, we will draw it. Assembly jig locator looks like. Так, I would better do it like with copying of this. Assembly jig locator. If you remember, I said that in some cases, even skins are not preliminary deformed. They will be placed to locator of appropriate shape. And finally, and next is similar locator and so on. And finally, they join it to the skeleton of the jig and they create some assembly jig finally. Sorry, pictures, of course, as usual, ideal practically in their quality and beauty. Unbearable beauty of pictures, I would say. Well, what should be provided? Where the elements to be provided in coordination? Now it's outer surface of skin and inner surface of assembly jig. And what does it mean assembly component to tooling coordination. Say me please, until I draw the next thing, say me please, how do you think what determine what is responsible for the shape of the rib and for the shape of the skin? Of course, rib was produced on foam block forming die, and skin was produced, let it be by stretching or somehow some bending punch. So we have on one hand tooling in the view of form block for the rib. You do remember how they looks like already? No, at least half of you supposed to remember after they studied this course. And on other hand, we have tooling bending punch for the skin. And in their case already we have surface here. No, let me not to draw much here, and the whole surface. Oh, sorry, the whole surface of this bending punch, almost the whole, as we understand, coordinated in terms we provide coincidence. Next, three objects. Literally, we're interested in the shape provided with skin and nose rib. But as I already said, you partially maybe skin will copy sizes from assembly jig. So all those group of couples, they are important in manufacturing. And question is, may we use this technique that was relied upon the individual sizes of objects, this system of fit and tolerances. It's also method of coordination providing system of fits and tolerances. It's method of providing coordination. Yes, when it comes about fits, it's about error of coordination between two objects. May we use it for airplay? I hope you already understand. No, we can't. Only for some individual elements only. Why? Because our object has peculiarity. This peculiarity I'm already perforated your brains with. Peculiarity that responsible for specific methods coordination, let's say, who is guilty, low stiffness, airframe components, they, as a rule, of great overall sizes, but they are thin. And as they are thin, they are not enough stiff, considering their sizes. They are trembling in hands. We have seen it already in movies, in videos about different manufacturing processes. When someone takes skin in hands, or even rather stiff profile, and this profile is dancing and twisting in hands after it was with very great difficulties it was manufactured. And understanding this we can't rely upon the properties of objects themselves, let's say, being manufactured with very high accuracy, we go into specific methods of providing the coordination. No, and on other hand, we're using specific methods of assembling with using of assembly jigs. These assembly jigs may be of different types. Assembly methods may be with different principles of compensating of errors during assembling, of providing interchangeability, and so on. So assembly methods, it's another story for half of year additionally. And we need to get some basic idea now about coordination and to be familiarized with techniques that used in aircraft manufacturing, being used earlier, used now for providing of this coordination between objects. Now let's try to see first some definitions that you already partially seen from my slides about these matters, and time to time I will refer to Telegram, maybe to different books. No, be attentive. Not everything it's necessary for you in this discipline to understand actually. But some names, at least, some general approaches, I need you to understand. And moreover, to motivate you, in test, you will find some questions that refer to this subject. Look, what we understand as coordination, according to our standard process of matching the geometrical parameters of objects of coordination. What are objects of coordination? I'm already said. Either it comes about assembly components or element of tooling. So coordination is understood as process of providing the matching of geometrical parameters of object. Now pay attention that it comes exactly about the geometrical parameters. It means the geometrical accuracy we're interested in, geometrical quality. And we talk not only about airplane pieces, but also a tooling that we use in manufacturing. And this tooling may be, as I already said, you at least two big groups: tooling that used in manufacturing of parts and tooling that used in assembly. It's so-called tooling of the first order, tooling that contacting with parts, with assembly components. But dreadful truth will be that we have a lot of tooling which is necessary to produce the tooling itself, the tooling of first order. And this second line of tooling, or we call it tooling of second order, what is standing behind the, let's say, real tooling working in a shop. Typically, in a shop, you have tooling, as I already said, you that working with some parts or with some assembly units of different complexity. And this tooling is used in manufacturing and may be changed sometimes during the program. If you have a long-run program for some tens of years, for instance, maybe someone producing airplane, 20 years, 30 years, may happen. Like Antonov 2, for instance, or like Boeing 747. No, of course, they significantly changed some the airplane itself, as I said you. So tooling, it was necessary to change whatsoever. Tooling each some years you need to change in a shop. But this tooling that comes as a new in the shop, it should be completely of the same sizes and shapes that was previous tooling. What for? To provide interchangeability of objects that you do in manufacturing. Not even coordination, but at least interchangeability. And this fact, we already fix it in our mind. How to reproduce tooling in some years or in some tens of years. And especially if we're talking about previous ages, let's say, of our industry, not about nowadays, but what was 30 years ago, 50 years ago, how they did it. Next, let's see once again two slides. What all this matter of coordination. I didn't say one more thing. As coordination, we understand the process on one hand, but to be frank, in English it will be a little bit easier because in this case it will be called coordinated objects, coordinated holes, coordinated contours. But in our language, the same word describe both the process and result of this process. So if objects coordinated, it means that it's provided the commonality, the similarity, the matching of their sizes and shapes. Under this beautiful collocation geometrical parameters, it's hidden mostly story about shapes and sizes, mostly. What all this is directed for? Why we do it at all? We do not understand what we do, but why at least we do it. As you see, the purpose is to provide, in the most simple way to explain, to provide assemblability while manufacturing, in order we may assemble the airplane, and to provide interchangeability in operating, because time to time it's necessary to upchange something in airplane. To make some repair on one hand, or on other hand, you do remember what I explained it. I hope you do remember that airplane may fly, for instance, 4,000 flight hours, and engine able to fly to work only 6,000 of flight hours, and it means during your airplane life you change engine 5-6 times, and each time this new engine should fit to the old airplane. they should be interchangeable, these engines. I may give you another examples, but the general idea you understood. In aircraft operating, more people more interested in interchangeability of components, and while manufacturing, we are much concerned about the assemblability of the whole. No, of course, it's provided on on one hand by the interchangeability that we have 200 of objects A and they are interchangeable. But despite they are interchangeable, they may be not mating to the object B or to some of the 200 of object B. And that is already matter of coordination, how to provide their matching. Have read, yes? What it for? Always the same. To save money, to save time, and preserve quality. Now, of course, quality is on the first place. We have to preserve quality. And each time the same story, money and time reducing. What I understand is these geometrical parameters of interchangeability. It comes about, as you might see, surfaces, contours, axes, and their mutual position, some systems of objects. Not going to explain much about this mutual positions or positional relationship, but just recollect the definition of bases we know. Bases are surfaces, lines, and points that determine what we understand as base. Surface, line, or points that determine position of the object with respect to some system of coordinates, or with respect to another object, for instance. Look, it's rather similar story. Surfaces, contours, axes. Practically, we may say that it comes about points, because axes, they usually, we're talking about axes of holes. So somehow it's remind us story about bases. I hope you already understand. And what we understand as objects of coordination, as I said, you objects, it's something that carry these geometrical elements or elements with those parameters. So it comes about surfaces, lines, and holes. Yes, which are placed somewhere on. Where on? Either it's some airplane component, no, like rim of the frame, or web of the spar, or cap of the rib, or whatsoever another element of airframe. Typically, these techniques of providing coordination, they are directed exactly onto airframe elements. And on the other hand, we have tooling. The tooling, which was responsible for manufacturing of these assembly components we're talking about. Well, so object of coordination, I'm already said it, those couples, you see. On one hand, parameters, these parameters may belong, these elements of coordination, they may belong to the same assembly component, to the same part, or they may be on two different assembly components, or they may be even in non-coincidence, non-conjugating assembly components. That is the weirdest idea may be, and the most difficult to understand without example. Let's go into example. For instance, you have the spar in the wing, rear spar. And on this spar, you have brackets. Let it be 3 brackets. And what for? We are going to place there, we have a wing, and in rear spar we have brackets. What for? To attach here the, to hinge there, flap or aileron or whatsoever. And in flat scheme, it's okay, it's normal. What are parameters of coordination in this flat scheme? What an ugly scheme. Sorry. Theoretical outline of the wing, and here is we have a flap and flap hinged onto point. Point belong to the, nothing is already visible in this picture. Point belong to the bracket. on one hand, and in flap they have one more bracket. So this point axis of hole should be coordinated to the contour. If it will be in wrong position, what happened to the flap? Flap may stay either higher than necessary or lower than necessary. It will be out of the theoretical airfoil. Yes, on one hand, like this. And it's the case when we're talking about two parameters, coordination in one object. In the wing, we have to coordinate contour and hole of bracket. So seems like there are two different elements, but they are in the same object. When we're talking about the parameters of conjugated assembly components, easy peasy to understand at all, do forgive me. This one has bracket and this one has bracket. Holes should coincide. Yes? Yes. Next, non-conjugated. It's not one bracket. There are system of brackets. And if only your brackets, let me to draw a line normally, not in the same axis, even if everything is ideally coincide, if these holes not in the same axis at least a little bit, like dozens of millimeter, yes? No, I mean some tenths of millimeter. Flap already lost in their functionality at all because it does not rotate. And that is parameters of so-called non-conjugated assembly components. Now, next it comes about tooling, you understand, and we have next some definitions. Before we go into these next definitions, maybe we need to recollect the history of aircraft manufacturing at all, what it started with. And in these terms, it should help us story about manufacturing the not airplanes, but sea vehicles, ships. Doesn't help, must be. I need it in English first. And now we will try to find English. It's appeared more simple. We see people right now, certainly they are on the floor, yes? As I said, I think we need to go into my Telegram channel to find pictures that related to the matter. It will be more simple. Loft. Or not simple. Oh, simple. Here is. No, as I said, more simple. How to make it visible to you? Look, pay attention to the backside. On backside, you see a picture of ship, ship vehicle. Let it be sea transport vehicle or ocean transport vehicle. Do you imagine that now we are in 17th century, somewhere in Europe, half wild by that moment yet, because it was the early period after so-called medieval. We have no secondary schools in big amount. We have no in modern understanding at all. We have no a lot of literal people who understand text and values from paper, for instance, to read. Not much books at all. Of course, engineers already existed, but it was little amount of people engineering possessing the engineering skills. And people need to produce a big amount of ships. No, Great Britain colonizing due to their traveling to different countries, to different continents, colonizing the territories. Spain also, Spain, Portuguese, they were much involved in all this process. And in order to travel, in order to provide merchanting with different countries, they need these sea ships for military purposes, for transportation purposes, so on, in big amounts and rather big ships. How to make some hundreds of people who do not understand neither text nor values, figures. Moreover, they do not understand engineering drawings, how to make them to produce all the elements of the sea vehicle exactly mating in the future. Remind you that it was made of wood, and it means that if something was cut wrong, it's already wrong. It's not about to be changed. It's not metal that may be deformed, redeformed, and so on. How they been starting their work? Originally, the drawing of some ship, it was drawn in scale. Engineers creating pictures in scale, sometimes less than real one. But next, this drawing was redrawn in scale 1:1. But only once it was redrawn in scale 1:1. And where it was redrawn, look on the picture. What do we see? It's redrawn on the floor. And they really created big, no, it's not even building. It was big wooden floor of higher quality, polished one. And in order to protect this drawing for some years next, they constructed walls, no, of course, with great windows, as you might see, and the roof over this. And all together, it looks like the loft of building. People, do forgive me. I need charging device for a second. Loft or attic of the building looks like this, usually. But of course, of very big height, usually. And maybe that is why those drawings, they start call it in English, loft. Now language we have another name, and this another name came maybe from French. Plus. And name loft, it's widely used in English in both meaning, as I already said you, as highest floor of the building, typically technical one, or as a drawing in a scale 1:1 of some object. Theoretically, they were interested in exactly in the theoretical lines. Let me do. Here is. No, it's illustration of work already in 40 years of previous century, taken from American book. Look, here is. Look, as only I touched something, it's disappeared the name. Loft floor. So call it loft floor. How people work on this loft floor? They created drawings of theoretical outlines of the airplane. Something like this. You already seen these pictures. These drawings were drawings according to some rules, let it be. And they contain only outlines. One of these outlines being measured, one more, the last one, measured, and all other were constructed by using of means of measurement of whatsoever. So only one, no, the first and the second contour were calculated by tabular data, data given in the tables of Air Force, for instance. All other being constructed, and if even something was coincidence with some little error, next it will goes into Syria, into aircraft manufacturing with this little area, with this little error. If even there is some deviation, like plus minus 0.2 millimeter, let it be such deviation. but this deviation next will be replicated into all the next tooling and parts. And finally, objects being made from this original drawing that was with little deviation, let it be. Of course, it's not welcomed, let's say, but it's maybe, yes? Finally, these little deviations meeting at the end, as they are all repeated and reflected in manufacturing, they do not enforce the assemblability of objects. And from these lofts, next, they manufactured their templates. Now we see how people comparing thank you, much useful. How people comparing their that one, yeah? Comparing the templates to loft, to contours of loft. For some reason, they place it here the system of templates and compare it to system of to the line of loft. And what the template is? Template is the piece, flat piece, usually. We have only two exclusions. Flat piece of metal or wood or hard paper or whatsoever in manufacturing of modern airplanes usually comes about the metal, of course, that repeat contours of object or holes in the object, maybe some another lines in the object repeated, because we have a great variety of those templates by their functions, by their purposes, let it be. But in general, we need to understand that template, they are pieces of metal or pieces of wood, flat, that repeat contours of either parts or tooling. Well, and next, by these templates, they produce tooling, copying from templates. Next, it was after tooling, they produce parts, and next, assembly tooling, which is also independently produced, meet with parts that produce it on another manufacturing tooling, and everything should coincide, everything should give final contours, outlines of the airplane. Literally, those lofts and templates, they were something like modern 3D models. But these 3D models being, not that one. That one I need to close. What I opened standard for you. That is our old Soviet standard. And look, we have in this standard, it has it's explanation about terminology, about rules, and so on. What we understand is that another kind of loft, because we have different kinds of loft. It's so-called theoretical one. Theoretical show only theoretical outlines. And next, it's copied to another kind of loft, which is called design loft. What example of design loft, despite it's here written their drawing, design loft will look like this also. Design loft will look like this, but this thing is made on transparent film. Вот так. And this transparent film, it's give you opportunity to make a photo, for instance. No, it's already difficult for you to imagine, maybe, because you do not remember those photo cameras that your parents used widely. Now you get used to digital camera, maybe. You do not understand what does it mean. Film in photo camera, negative in the photo camera, and so on. But nevertheless, those things that looks next like normal assembly drawing, but only in scale 1:1 already, they've been created by manufacturing engineer at the enterprise, by production engineer. It's the enterprise where airplane will be constructed. They've been created from loft, which is theoretical and contain only contour, and watching the assembly drawing drawn by designers, maybe this drawing was not even in scale. Maybe the drawing was No, I mean in scale 1 to 1. Maybe the drawing was in scale 1 to 2, 1 to 5. Or what is worse, even the drawing may be in a paper, may be given in some places. Let it be some general contours, they are given in scale 1 to 10. Next, some pieces shown in 1 to 1, and something like this. It's like chaos of different pictures in the drawing, and drawing it's not A1 or A0 size. We call them sheets, no, in terms that those drawings, blueprints, so called. Простыня, bed sheet. Sheet for the bed. Do you imagine? And why? Because one drawing may be in 5 meters length or something like this. Some formats A1 combine it one by one into a very long sheet. And one object, no, flap, for instance, may be given in pictures of 3 such bed sheets. Do you imagine? And how to work with this? How to make tooling from this, how to produce parts from this, and so on. In order to reduce difficulties in manufacturing, it was once redrawn all objects that is exist, all the parts, all the whatsoever exist in this assembly component. It was assembly unit. It was redrawn in one theoretical loft, in one design loft. Design loft looks like this. Theoretical loft we have already seen. What here is theoretical loft of some ship, of some boat, you see. Yes, and this ghost is exactly for both our airplanes and for the boats, for the sea vehicles, for ships. So let me to close it. What is next? After people been working with those templates, and the worst was creating of jigs, assembly jigs by templates, because jig consists of some subpieces, and it's necessary to, let me to drop here. I open it on the place I meant to show you, but now jumping, sorry, a bit, to find another picture. After people been trying to assemble the jig by some different flat templates that been separated in the space, and it was necessary to measure them, distance between them, to align them all, and so on. After people worked in our airplane manufacturing, worked for 20 years like this, it appeared that this technique is not given the high accuracy of airplane finally. When it comes about sea vehicles, they are not flying in the air, and they are not traveling with very high speed, you understand. But when airplanes exceeded the speed 300 of kilometers, what is actually not much speedy, as we understand now, yes, because it's the speed of modern race automobiles. And when airplanes exceeded this speed, it appeared that the techniques of coordination with using lofts and templates does not give proper results in manufacturing, in serial manufacturing. And people start seeing how to improve quality of assembly jigs and tooling, having no choice actually. They still have only either flat drawings or flat lofts. Next step was manufacturing start with lofts, no, not manufacturing, pre-manufacturing, technological preparation of manufacturing. It start with producing of lofts. Lofts, once again, remind you, flat drawings, either of theoretical contours, so-called theoretical loft, or of assembly unit cross-section design loft, or it's maybe so-called control print photo of design drawing of this design loft that looks like design drawing, but not in a paper, in special thin transparent film. And this photo onto metal it's called already the control print. But they are all flat, you understand, as well as templates. What people start making? They start doing first three-dimensional mockups. They did lofts, next pass to the templates, and next out of these templates first, instead of produce tooling immediately, out of templates they made three-dimensional mockups. And next they already use these three-dimensional mockups as the tooling for manufacturing of another tooling. And also here it's appeared that more convenient to have some different three-dimensional mockups, their copies, let it be. The very first copy is called Surface Standard or Master Mockup in English literature you might find. These master mockups, or in our understanding, Surface Standard, it's the whole solid object that repeat only outer surfaces of airplane. It consists, of course, of different aggregates. Actually, laws also issued for different aggregates because it's not possible to reproduce contours in three cross sections in the flat piece of so different objects like fuselage, for instance, and wing. You understand? Do try to imagine. And mockups the same. They produce it separately for all the another aggregates in another surface standard. Next, they are joined all together. They are connected, aligned, checked whether they give necessary quality of airplane finally. In this stage, it's possible to find some mistakes, for instance, in the design documentation or in technological documentation that already appeared. And after repairing of these, let's say, mistakes, they goes to the next stage. Next stage, we don't need the whole mockup, the whole surface, for creating of assembly jig. In assembly jig, we need only some cross-section. I hope it's visible for you here. We need some cross-section. And as we don't need some cross-section, maybe we don't need a solid mockup, which is this solid mockup, this surface standard. It's like, I'm already used this collocation. Holy cow, yes? We should carry it with very high accuracy, with very high love, in order to save it for years, for some tens of years, until you do not finish your manufacturing, because it's the grandfather of all your tooling. It's about the story like you need to reproduce tooling that give the same results like tooling being produced 20 years ago, for instance. How? For instance, by copying from this pre-tooling, this master tooling. And master tooling should be not even touched one extra time. It should be saved in special place. It's no, like we worry this master tooling, we bothering to the master tooling only in extra cases. I can't even imagine those extra cases, to be frank. But in order to pass from solid tooling like this to tooling which more remind frame-like tooling like that, do we see? We have intermediate tooling, some like negative copy of solid standard, surface standard. And this tooling for copying the surface standard, it's very similar to the tooling that is called assembly jig. It's similar, but it's sometimes more accurate. In arrangement, it's maybe rather similar, but sometimes more accurate. Next, how we passing, by the word, from one to another? By molding, by using methods similar to casting. And next, people goes into making backward copy, and this backward copy already did not repeat the whole surface. That is so-called master, surface standard or master mockup, and that is mounting standard. Surface standard and mounting standard. Why it's called mounting standard? Because its purpose to be used while mounting the jig. Well, but with appearing of next type of airplanes, no, you understand this surface standard plus system of counter standards plus system of mounting standards. Next, all this, it's not really used in manufacturing. All this, it's necessary only in preparing of manufacturing. And next, all those dreadful things should be saved for 10 years, for 20 years. And some of them, like mounting standards, time to time may be used in a shop. What for? Either we need to produce one more assembly jig of the same sizes and shapes, or we need to control, to check, to control its wrong work, sorry, to check, to inspect assembly jig somewhere in a shop. And in this case, how we may inspect it? We bring mounting standard, compare it, install it in the assembly jig in the position that it was preliminary when mounting jig was first created, and compare deviation of locators of assembly jig from mounting standard contours. Such kind of inspection with natural carrier of sizes and shapes. And that's it. Practically, it's not used in manufacturing, but it should be saved for long years, and the whole even producing of those tooling, it's already cost us a fortune of money, and next saving of it in special condition also it's necessary to maintain it with very high accuracy. It's extremely expensive. Even for little airplane, it's extremely expensive, but it's worthy because it provides high quality, especially for speedy airplanes. Yes, but maybe we don't need already such high quality, people have decided, when big wide fuselage airplanes first has appeared, airliners. Then mock-ups yet been in wide wooden mock-ups, originally made of wood, in full scale. Do you imagine? I do not remember, have I already shown you or not video about Boeing 747 where they show whole scaled wooden mock-up of Boeing 747. May you imagine this? It's middle of 60th years of previous century. It was the only way to produce accurate tooling at that period. We have no computers, we have no CNC, and so on. But maybe we may save money somehow, people thought. This technique is relied upon the copying of sizes, you understand? But is it possible to use some techniques that use means for measuring of sizes, not for copying of sizes? And people start think in this direction already. And due to this has appeared one more group of methods which used, on one hand, being used lofts and templates, and on the other hand, while manufacturing of big assembly jigs, it's used measurement, but measurement was very specific. Rulers. What is it? It's a ruler for measuring the sizes. Three-dimensional ruler, it's called instrumental stand, and it's a tooling also of secondary kind, secondary tooling may be called. But this thing, it's able to measure sizes with accuracy plus minus 1/10 of millimeter. 1/10 of millimeter. Accuracy of given here, it's accuracy between holes, between divisions in this instrumental tool. What are divisions? Holes, not scratches on the ruler like we get used, but holes. And between these divisions, accuracy is plus minus 1/100 of millimeter, but results of measurement of manufacturing by these rulers are plus minus 1/10 of millimeter. What you may provide, what accuracy, by using normal ruler with millimeter divisions, plus minus 0.5. And this one, plus minus 0.15 times more accurate, despite of great sizes and so on. These technological rulers that may be flat, two-dimensional only. In this case, they are called loft conductor. No, to be frank, when they are accompanied with the drilling machine, it should be called loft conductor. It's two-dimensional ruler, it's three-dimensional ruler. And those rulers are used for measuring some elements in assembly jig positions while manufacturing of assembly jig above the all. Also, they may be used in manufacturing of big-sized tooling, for instance. In order what? On one hand, accuracy of these techniques will be already a bit less than accuracy of techniques at using standards. On other hand, this thing, it's not be a piece of expensive trash after you finish program of manufacturing. You may use it for another airplane or for the whole dozen of different airplanes tooling. And because of this, it's less expensive. You understand? If something is more universal, it's more expensive in manufacturing. It's not so maybe simple in manufacturing. It's maybe not so convenient in manufacturing, but it will be sometimes less expensive. Well, and let's go here right now. What I've been talking about different, no, you see, different loft, mock-up, so on. We have an idea that we have some origin of coordination. If I come back to this dreadful picture, origin of coordination actually is here, where these branches start separating onto different sides. That is so-called origin of coordination. But you see, it's preceded with one more thing. This one more thing is origin of information. Origin of information. Next, we have so-called origin of coordination. In case of using of lofts, quite clear that origin of information was system of drawings, theoretical drawings, assembly drawings, plus we had so-called theoretical tables of profiles, plus we might have some mathematical models. Something may be described with equations, so-called analytical information for aircraft construction. And all these various sources of information, they are called origin of information. Origin of coordination is something that is last in the chain of this size transferring. No, literally, they've been copied, you understand. And next, we have, it's disappeared. We have here. Next, we have either drawing. It's possible when we are working with stiff, massive parts. I'm already said you. If we have drawings with linear and angular sizes, everything is simple, everything is repeatable. We may use system of fits and tolerances, no problem. Let's work. But when it comes about large-sized objects of very low stiffness, because they are seen typically, what we need to go into? Lofts and mock-ups. Look, loft, the very first loft in this picture. Here is. Again, it's not the picture of engineering book. It's picture about theory of evolution. Here is you have some origin of information, and next you start copying these origins of informations into, for instance, theoretical loft. Theoretical loft is copied into design loft. No, it's combination of theoretical loft and origins of information, which looks like practically as assembly drawing, but in special carrier. Next, you copy it in a control print. And in case it was traditional loft template method, from control print you do templates of jig, templates of tooling, templates of whatsoever. Control print is origin of coordination here. It's the sort of loft once again. Next, if we're talking about creating of mockups, theoretical loft, design loft, control print, templates, and out of templates we construct mockup. How we construct it is another story. Mockup, and next from mockup we start making either another mockups. If we're talking about assembly jig, counter standard it's called. Counter standard, mounting standard, assembly jig from this mounter standard, so on. If we're talking about tooling, mockup and counter mockup of the tooling, it looks like we've seen it. Not everyone have seen it. Let me do. Half of you have seen it. Sorry. Wait a bit. Drawing. Maybe it's preceded by this picture. That one. Somewhere here. Yes. What here is idea of making the tooling by copying principle. No, at least half of you have heard this dreadful story. Wooden mock-up. Next, from wooden mock-up, we do counter mock-up by molding also. Next, this thing made by molding, by direct copying of this surface to some plastic mass, for instance, or something like this. Next, it was intruded, let it be, into mixture like sand with binder, and removed, of course. Empty cavity here was filled with special metal. This special metal typically on the base of lid, this lid with something in order to have good castability and repeatability of shapes. And here is we have filled already the cavity in this mold with the metal. And next, finally, this thing, it's, what is it? It's the dia block, let it be. But how to have punch now? How to make punch to this dia? And you see, we go into the same, but now the dia block may be already the, what here is the dia block. You see, dia block is the mold for the punch. We're placing the real dia block in the special box and so on, covered with separating elements in order to prevent adhesion and in order to imitate thickness of the part that will be here next. And fill again with the metal. And now we have both punch and dia block identical in sizes that able to be used in so-called drop hammers manufacturing. They are drop hammers, some in manufacturing of such parts. Well, and when I'm talking about copying method, I'm talking about things with applying of these principles of molding, literally. However weird it looks like, it's used for manufacturing of tooling. Well, and let's come back here. So when people understand that maybe we may use something else. One more thing. We have origins of coordination. I'm not talking yet about this. And we have means of coordination. From those origins of coordination, it's not compulsory the tooling next or ready part next. Maybe from origin of coordination, maybe next will be something, another element of secondary tooling. What this element of secondary tooling might be. From lofts, you do templates, for instance. Templates are considered already like means of coordination because they are intermediate between the tooling or part and origin of coordination. I did mistake here when I made that file. Here it should be word standard and here should be word mockup. Sorry. And what people has invented, I said, to use so-called instrumental means. And originally, those instrumental means were only, as we might see, instrumental stand, loft conductor, rulers with holes, tables with holes, and so on. Mostly. Next, with appearing, instrumental means are also simple rulers. Even the rope with the heavy lead, the heavy piece of lead at the end, it's so-called plumb. It's also instrumental mean. And all the measuring devices, all these optical devices, for instance, with appearing of lasers, laser devices, they are also instrumental means because they are universal. They measure sizes. They're not copying sizes, not comparing the sizes, but measure the sizes. Of course, they demand the operator to be skilled in such measurements. They are not so convenient, I said, in using, and not so primitive like templates, but they are not so costly as making of lofts and templates. But despite to the fact that I said lofts been costly, they've been used together with those instrumental means. People has no choice actually. We had no computers, we had no three-dimensional models, and so on. And next, with developing of technology in terms of machines of different types, including computers, has appeared one more way to represent geometry of outer surfaces in the view of 3D models. And in this case, those 3D models, they are also close, we refer them as to origin of information, because actually they are substantiators of our theoretical drawings, mostly. Theoretical drawings, assembly drawings, and so on. So 3D models, they are maybe considered like origins of information. And what will be the origin of coordination then? Programs, CNC programs obtained by means of computer or written directly. Actually, the CNC machines, CNC controlled machines, like milling machines, turning machines, and so on, they appeared around 20 years earlier than computers able to work with 3D models. And people been programming those CNC machines in half manual mode. It means that they wrote programs codified in the system of commands. Next, they use even hard carriers like punch it strip. I will try to find it right now, not sure. If you ever seen something like this, have seen or not? Never, ever. We've been looking at such things. And actually, it was program for machine, what you have seen right now, either a perforated card or perforated strip. It's a program of machine, and machine reading these clearances, these gaps, understand it as symbols for itself as a system of commands. Even normal compute, no, normal, it means something that not related to machinery, something that necessary only for calculations. It also was driven like this with using of these perforated strips and perforated cards. Well, the keyboard in usual, no, that we get used to, it's appeared already approximately in 80 years of previous century, like 35, 40 years ago has appeared keyboards joined to displays and so on and so forth that we get used to. If you ever have seen American movie Matrix, you may have some idea how people worked to computers where you watching the screen only with line of values and commands and so on. No any graphical information, graphical interfaces in the appearance that we get used to. Well, let's continue because we need to finish finally this story. So origin of coordination now maybe also CNC program. And what is the mean next for mean of coordination that working with the CNC program? CNC machinery or laser tracker or coordinate measuring machine or and so on. Any universal device that able to work with software, some computer software, and computer software has programs to control the work of these devices, it will be already considered like instrumental mean of coordination. So this system of names of concepts of ideas, it's include, as you understand, all variety of possible decisions in terms of providing the coordination and ancient one and new one and so on. And it's based on separation of all the things that we are using onto some levels, and those levels are slides. I have it in Telegram, but I think it will be more simple for me. I- It's you after listening to the course. Forgot to show to everyone before. No, okay, you've seen it already. Those levels are, look, you see now. Those levels are at the top, of course, we have here the assembly units, parts, assembly units, whatsoever, objects of our manufacturing. Well, here is about their geometrical parameters of interchangeability and coordination. And if we draw here the line, thick line, somewhere here, between third and fourth law, it's like we separate the pre-production from manufacturing. And do remember, pre-production is produced once, we do something once. And here it's serial manufacturing, that it's repeated, repeated, and repeated. And decisions made in pre-production, I hope you already do remember this. Next, they are repeated in manufacturing. In case they were bad decisions, it means that in manufacturing, you time by time, repeated, repeated, and repeated, you're losing money and time. In case you made brilliant decisions in this period, you're saving and saving and saving money and time in manufacturing. Next. So pre-production period is extremely important for manufacturing. Next, for normal work of manufacturing. Well, what we see here that we separated all the things we are working with onto some levels, like organize it into our minds a little bit. You do remember this story about obsession of any manufacturing engineers of technologists in categorizing of everything in classifications. That is a result of our obsession also. And moreover, I should say that we create so-called diagrams of coordination, some special drawings which contain not in such a picturesque way. I hope you understand. It's only for my students some no for explanation to my students some things they look so beautiful, like colorful with photos of equipment or photos of parts, but really they looks like block schemes, block diagrams for of algorithm of computers. And such diagrams of coordination, while technological preparation of manufacturing, they are necessary, they are necessary to understand and to fix decisions somewhere in a paper or in computer, how we're going to organize manufacturing and what is necessary to do while pre-production in order next in manufacturing we have high qualitative results. Approximately it's like this. Well, what I didn't say yet, uh, let me to say, no system of names. Next, it's this one, what is called method of coordination. It's in our standard. It's called said like it's pattern of combination of origin of coordination and mean of coordination. Depending on what method use, it may be called loft template method, or loft standard method, or program template method, or program instrumental method, and so on. By now, of course, the most popular is the program instrumental method, which use three-dimensional models, which use CNC machines, and so on. But truth is that even in very high sophisticated manufacturing, templates are anyway in use due to their cheapness above the all, cheapness and simplicity in using. And in this case, we may talk about using of program template method in our manufacturing. No, how to call it, it doesn't matter actually right now. I need you to remember that we may start with some not even carriers of information, sources of information. And next we have two ways to go on. Let me to show you, to jump you to find it quickly, I have copied it into my standby place. Oh, I see, I did it even twice. And here is we see, like this. We see explanation. This explanation is referring to different ways of creating of assembly jig, actually. But in general, it comes about the two different approaches to coordination. On the left, I'm afraid to touch it or it will jump the text again. On the left, we see yellow real object. This real object, for instance, mountain standard, that is looks like skeleton of some wing or fuselage or whatsoever. And contours of this real object will be copied onto elements of jig. And moreover, elements of jig will be placed, assembled in accordance to this yellow object. And on the right, on the side that is here, sorry. Okay, you see it. On the right, here is another approach. And this approach, yes, it may include, or in modern conditions, not even necessary, this yellow object. In in 60 years of 70 years of previous century, it was necessary to have at least templates in order to realize this method. Will not explain it right now, sorry, lack of time, and it's not so simple matter really. But it's already been used with measurements. What is measured? You see position of holes of different elements of jig, and next, by combining of these holes of different elements, you may place all the elements of the assembly jig in the correct position. But really, you're not interested in the position of assembly jig elements. You're interested only in the inner surfaces of assembly jig, into these surfaces, in the system of these inner lines, inner contours, provide you assembly basis for locating of your airplane pieces. And you see here is explanation that we have practically only two techniques. One technique is with relying on the copying of sizes by molding, literally by molding, you've seen it. And another with measurement of sizes. That's it. In order to show you the mock-up, let's try. That thing I haven't prepared. For instance, look. That is airplane, you see, Bombardier de Havilland. And mock-up of it. What this mock-up is necessary for? It serves two different purposes. It's mock-up of fuselage airframe. It may be used as mounting standard, but that one is also used as a volumetric loft, so-called. You see, they coordinate here, they check coordinate positions of all the wires, of all the inner elements of pipes and another equipment, for instance, in order to make sure that all equipment correspond to sizes, to compartments of the airplane, that all the places has approach while assembling and so on. Before appearing of 3D models and so-called virtual assembling, that was the only way to check all our decisions that we made on drawings before we started the repeating of our mistakes, do forgive me, in real manufacturing. That one we have seen. That is, oh, here is assembly jig actually, in half destroyed way, because not all locators are shown. That is also assembly jig, and you see it's look completely different. But it was assembly jig for panel. Wait a second. We're searching for mockups. We're searching for mockups, but what we have found the story about laser tracker. How no, it's necessary to show the movie for you to understand and so on. Now we see process of inspection. Process of inspection with some snaps from screen I made once. Process of inspection, you see laser tracker, you see boy who no, maybe 18 years old, 20 years old, after the school, without any education, without anything at all. And his function only to carry this reflector to different places, actually. And the only engineer is here taking place in this operation. So laser tracker, software, and one engineer. And this is, you understand, transporter of this reflector, this boy. With all the love to this boy, he is maybe replaced with another boy or with robot or even with trained dog, do forgive me, in order to place a reflector to that to another place like this. And next, laser tracker inform about coordinates of these special places, and it's compared into 3D model to 3D model in computer. And finally, no, that is not ideally visible, but visible. So-called point cloud has appeared, and finally, they may do conclusion about the quality of this aircraft. But I meant to find something else. No, that is so-called, what for instance, that is so-called principal diagram of what method. That is loft template method. Да? No, standard template method. Yes, standard template method. We have lofts. Next, they are through the system of lofts translated into templates. We do the exact copy of aggregate, and this exact copy is different in different ways. Copied on one hand to the tooling, you see, to the tooling for parts manufacturing, skins, bending punches, so-called sand molds. In order we might do bending punch that correspond to the outer surface or to inner surface of surface standard, it's necessary to do counter copy. Not quite the same as here and there. And on the other hand, assembly jig. Remember this? Quite the same. Oh, have found this file with diagram. It's prepared, as appeared. Usually, though it's diagram for one part, but do imagine that you have some of them, dozen of parts, for instance, in assembly. And of course, then it will look something like sum of parts. And for each of these parts, it will be one diagram that consists of some sublines. Algorithm of manufacturing, of pre-production and manufacturing of one part here. Where have we been? In Telegram. We've been searching for mockup. No, I hope general idea you already understood. What here is, for instance, I'm not insist it's completely the same. Where is it? I had it somewhere. That is the nose fuselage. It's mock-up mounting standard of nose fuselage that been used in mounting the jig, for instance. This weird thing, actually, it's assembly jig. Assembly jig, Boeing airplane for using the so-called mock-up elements, mock-up frames during assembling. Oh, do forgive me, can't find some more photos immediately now. General idea, I hope you already understood. That one is not surface standard, it's mounting standard, it's frame-like, and that one also was frame-like. But where is this? Here is what that one. Also, something like this surface standard looks like, but that one is not even surface standard. Because surface standard, it will have completely solid surface, streamlined, without any scratches, without any dimples, only some drawn lines maybe on surface standard. And next you see system of templates being made from by sequential copying of sizes from surface standard. They do templates, and next from this template they will do another as a tooling for parts and so on. That was approach of 100 years ago, or even 50 years ago, or even 30 years ago, applied in manufacturing, widely applied. It's still in use, but not in such traditional way. In order to save money where it's possible, we go into using of cheap templates. In order to increase accuracy and save time of pre-production, of course, we use computers. Wherever it's possible to use CNC machine, we might use CNC machines. But how to use CNC machine for the simplest primitive parts manufacturing? It will be too expensive. We understand it, yes? Let's use some primitive means for primitive parts. But if it's necessary to use some tooling for manufacturing these primitive parts, tooling may be produced on CNC. And on one hand, we are saving money and time in pre-production. On other hand, we're saving money in manufacturing. Let me to show you one more movie and we will stop this dreadful class on this point. Typically, as I said, you students hate this subject of coordination, and I may understand them because when I was a student, sorry, I forgot to download it preliminary. When I was a student, I also suffered of all these lofts, templates, and other means like this to understand why they invented all these systems, why they use these complex techniques. Why? The answer of my teachers, I already reproduced it to another group of students, yes, to half of you. Because only this is working well in life. And
Most complex aircraft in the history of aviation now in production. Thousands of engineers are already working on the new Airbus long-range program, the A350 XWB. Wherever they may be in the world, they are all part of a virtual design office, where day after day, a unique digital mock-up called the DMU is being created. The DMU means that right from the design stage, the whole life cycle of the aircraft can be envisaged, from conception through to end of life.
The challenges of the
story we all know. But 20 years later, the A340 offered airlines such a wide range of choices that it was obvious that the days of paper and the drawing board were over. All the Europeans involved would have to work on a single document, a digital mock-up that would evolve at the same rate for everyone.
Mit dem Start bei der A38, please. We need to do the analysis before actually coming up with the real aircraft.
Hundreds of engineers are doing and what it looks like so that everybody could be working together with one synchronized model.
With the jigs and the tools.
C'est vraiment un outil.
This data is used for...
Est-ce qu'on peut passer les mains? Est-ce qu'on peut voir les choses qu'on doit installer ou est-ce qu'on doit travailler en aveugle?
It allows manufacturing and engineering to share the common data and a common reference. It's used in the development phase like A350 to simulate all the industrial manufacturing processes at the very early stage. This data is used for directly programming our machines, simulating the flow of parts, simulating the assembly of the different components, and checking that these components don't interfere with the jigs and the tools.
C'est vraiment un outil qui est
Or even incorrect data.
Eine Vorstellung darüber zu...
It's also a mindset.
So, general, you understood. I will send this movie. Actually, it's the whole series about the Airbus production, pre-production movie. It's very interesting. Interesting for first time, at least. And generally, you, I hope, understood. Now, we use, instead of lofts, we use 3D models. And these 3D models, they may be, it's like the same 3D models that may be placed in some computers in different places in different countries, actually. And people may have access to this 3D model simultaneously and work with different elements of this 3D model. Or it may be derived 3D models from this one. For instance, 3D models of tooling, next. Purposes it's used for, besides of its origin of coordination, it's also may be used in calculations, in CAE calculations, computer-aided engineering. It may be used in simulating processes, whether it comes about manufacturing process simulating, like flowing of metal in a closed die for forging, or it may be simulating of assembly, like we have seen spotted some piece, and so on. The variety of different functions, different purposes may be fulfilled next with this DMU, digital mockup, next. Now, once again, it's traditional approach. First, digital mockup. Next, from these digital mockups may appear again again may appear real mockups, solid one. And they are, no, will not search right now for photos. They will be used as mock-ups for manufacturing of another tooling, for instance, by molding. Because if we are trying to produce 5 pieces of tooling on CNC machine, maybe the same tooling, like 5 copies of the same die, or same die block or same punch. Maybe they will be too different, depending on the demands to parts accuracy. It's necessary to check by calculation and by natural experiment time to time whether it's possible to have completely identical tooling in order to have interchangeable parts next using some copies of this tooling. And do remember that the worst may be in terms of coordination that no, for China it's not so actual, but even in China, more probably no any airplane is produced in one enterprise. You incorporate hundreds of different enterprises, literally hundreds, in order to provide one airplane. Because components of airplane in one at one enterprise, airframe components, for instance, equipment, radio equipment, electronic equipment, software, everything, passenger chairs, whatsoever, passenger seats. It's too different to be produced in frames of one enterprise. And it's produced in separated enterprises. They are in different cities, in different countries, and so on. And result of their work next must have fit finally, geometrically fit above the all. How to provide it? No, in modern conditions, you see, we have approach with using of computers. In previous conditions, in our old circumstances, let it be, one-to-one copies of airplane lofts and the copies from copies template. And whether that approach or this approach, mostly it comes about when we're talking about 3D model and we do something from 3D model, we do another 3D model. What it's really about? It's again about the same approach. Look, it comes about copying principle. We are copying sizes, yes, but already in computer, virtually copying, let's say. And whatever modern approaches with computers or old approaches with loft and templates, we still mostly using these copying principles while pre-production of airplanes in order what? In order to provide as minimum as possible error of coordination, what we have started with. I hope you yet remember it. And these minimum errors of coordination next provide us what? Assemblability in manufacturing, in assembly manufacturing of airplane. And what we need is assemblability in manufacturing. And we came back to the same story. To provide quality with saving of money, time and labor input. No, I already said you, technologies, they have two obsessions, yes? Classifications of everything and saving money, time and labor input. Well, labor force. Well, people, hope to see you in our online class 2 more times. No, by now it's everything. See you. Goodbye.